I am a co-chair of the special interest group for applications. So that kind of covers basically running applications on Kubernetes, managing them, developer tooling, and especially the workloads in Kubernetes core, like deployments, pods, stateful sets, cron jobs, etc. And I'm also a core maintainer of Kubernetes Helm and charts, which is actually kind of now part of CNCF. A little bit about Bitnami. We kind of leads on 5 different Kubernetes projects, so we're doing quite a bit in the Kubernetes space. We've done some training for Kubernetes, and we're one of the authors of the Kubernetes cookbook for O'Reilly. We've developed so some of the projects that we've worked on. So Helm is kind of a big one. Hopefully you all know what Helm is, but if not, it's a package manager for Kubernetes. And we kind of got involved quite early on and helped them develop that, and also built out a bunch of Kubernetes charts, which is just the actual package format for some of the applications that we built at Bitnami. We've also worked on kubeless, which is the serverless framework for Kubernetes. It's kind of a Kubernetes native serverless framework. And it uses all kind of Kubernetes primitives, so custom resource definitions, or used to be known as third-party resources. A few other projects, so KubeApps, which we'll show you a little bit today as a result of the telepresence. So this is actually the project that we're building out that we use telepresence for. And it's kind of like a UI console for your Kubernetes cluster. It kind of augments the existing Kubernetes dashboard, but allows you to manage, launch, and deploy Helm charts inside the cluster, as well as kubeless functions, and also connect to the service catalog. Some other projects as well: kubecfg, sealed secrets, which is a way of managing secrets in your cluster, and Cabin, which is a kind of a mobile app for your Kubernetes cluster. So Kubernetes is a great production environment. I think we've all, if you've used Kubernetes before, if you've read about it, like that's kind of the big selling point. It's a great place to run containers in production. It has a lot of concepts built in, like things like ingress, config maps, secrets to manage how your application gets configuration inside it. So it's really just built for production. But what does the development environment look like on Kubernetes? Well, let's take a look at kind of like an example application that you might deploy to Kubernetes. Something like this. Typically, you want to go for that kind of microservice architecture. So you have like a front-end service. It's fronted by some sort of ingress, and then you have that connects to different services across your cluster, so like a comment service or a product service. These services talk to each other. There could also be a database service in there. So this is kind of like the typical application you might deploy to Kubernetes. And if you were to go and develop this, inside your development environment, how does that look? Well, you might be familiar with this, and actually just a show of hands, is anyone kind of doing this, like deploying your applications on Kubernetes, but then actually developing them using Docker Compose? And I saw a few hands go up there. So this seems pretty familiar to people. This compose file, by the way, is I've just extracted it from. We've changed it right now, but this is what we used to use for developing KubeApps. So you can see some of the KubeApps services there. So just to highlight some of the things that are going on in this compose file, we have config maps, which essentially are volumes, mounting in this config file from my host directory to a particular location in the container. Secrets, which it's not really a secret, but we'll just pretend it is. And then you have service discovery. So in Docker Compose, like each of the kind of labels are the names of the services. And you can just use the service discovery that Docker gives you to find those and connect to those. And also volumes. So here I'm mounting in I've got a kind of empty data volume that I can reuse. So if I restart the container, I have all the data that's in there. So all of these things Kubernetes already gives me, but I'm having to re-implement the for my development environment, and just write like a whole different YAML file to do with that. And every time I go to change something, if I add a new service, or if I change volume, or change the config map, add some more config or environment variables, I have to go and update both this and my Kubernetes production YAML as well. And I don't know about you, but and I like YAML, but I just don't like it enough to maintain 2 sets of manifests all the time. So there must be a better way to do this, right? And again, what if I'm using things like ingress or jobs or cron jobs or init containers? These kind of things are not built into Docker or Docker Compose, and I have to find other ways to implement that. For cron jobs, I may have to set up a cron container, which is separate to how I do it with Kubernetes, and run a process inside that cron container. Init containers, there isn't really a good way to do that at all. I'd probably have to edit the container entry point or run a container manually before I run my Docker Compose up. If I'm building extensions for the Kubernetes API server, so if I'm doing something with CRDs or building a controller, then I may have to mount my kube config into the container to actually make it work and connect to it. So none of these kind of options are really ideal. So I was kind of looking for a different way to do this, and something that would be a lot easier to use. So one option that comes about is essentially just running things on Kubernetes and going through this kind of build, push, and deploy cycle. So as a developer on my machine, I make some code changes, I go and build a Docker image, I then go and push that out to my Docker registry, whether that be Docker Hub or an internal registry, and then I go and use kubectl to go and update that. And that's a kind of cycle that I would go through, and it'd be pretty slow, right? I pulled this out of the Terraform stocks, and this is a good overview of what this looks like, right? So here again, as a developer on my laptop, I have the source code, I'm editing it, build a Docker image, push that out again to the registry, and then once that's pushed out, I can use kubectl and edit my deployment to set the image, the new image that I've just pushed. And it works fine. And I can actually test everything on a real environment, on a real Kubernetes environment. But it's just a lot slower. Every time I go through that build process, I'm having to build a production build of that service. I can't use certain development environment features that I get. Like if I'm working on a Node.js project or a Node.js server, I can get like kind of auto reload or refreshing whenever I make a code change. That doesn't work with this process, right? I have to actually go and manually run Docker build or and push out to the registry. So there's actually been some tools that have been developed to make this whole flow easier. So Microsoft came out with something called Draft, which allows you to essentially automate all of this by building a Helm chart and pushing out that Helm chart and building your images and stuff for you, and then upgrading that Helm chart inside the cluster. There's also Scaffold from Google Cloud Platform, which I think Ilya is going to show a demo of later as well, which essentially does a similar thing. So there's quite a few tools that are kind of automating this process. But I came across another tool called Telepresence, which is essentially what we decided to end up using, and so I'll show you a demo of how that works today. And we really liked it at Nami. We found it really, really useful. It's really sped up the development process for us. So Telepresence is a project by a company called DataWire. It's all open source. You can go to telepresence.io and you can find a GitHub repository. You can find out how to install it and everything and set it up. You can install it with Homebrew or apt or DNF, depending on what operating system you're using. But it's pretty easy to get up and running. And this is the way it works. So essentially you have, going back to this diagram from docs, you have your source code again inside your laptop. And just like you would normally, when you're developing an application, you start up a local process to run your application in development mode. And then you have this Telepresence client that's also running in your machine that acts as a proxy for a pod that's running inside your Kubernetes cluster. So essentially what you get is you get access to, it's as if your local process is running inside the Kubernetes cluster because you have this proxy set up. And you get service discovery, you get volumes, you get all sorts of stuff, but all on your local machine. And this Kubernetes cluster, it could be running on your machine like Minikube, or I use Docker for Mac Kubernetes, which works pretty well. But it could also be running in the cloud, GKE or AKS or EKS or whatever KS service. As long as it speaks Kubernetes, I think it works. So with the local process, again, you know, it's just like running your application in development in that Docker Compose file. You can take advantage of all the debugging tools that you have, the library load, all that good stuff. And as I said, you get service discovery of all the things that are in your Kubernetes cluster. You get volumes mounted, and it's just as if you're in the same environment. So you get environment variables, or the config maps that you want, but it's all in your local machine. So how does it do this? Well, the best way really is to show you a demo of how it works, to be honest. But before I go into that, I'm just going to show you the different proxy methods that it supports. So there's a VPN method, which essentially sets up a VPN connection using SSH shuttle or S shuttle with your Kubernetes cluster. And this works well with things like Go binaries, things that are statically compiled. The caveat is that you can't run another VPN at the same time, which is kind of a shame if you're tied to a company VPN or something. There's the inject TCP method, which I've been using, although it's a bit of a hack, to be honest. I think the upstream is trying to move people away from that method. But it basically injects a shared library into the process, which is why it doesn't work with statically linked libraries with the shared library. But it's another way of doing it. And then lastly, there's the Docker or container method, and that basically runs a proxy as a container, and then that proxy then connects to your Kubernetes cluster, and then any other container that you start with essentially a Docker run command will use that same networking stack. So you automatically get the connection that way. And that's kind of a better method, I guess, especially if you're already building containers and using containers. And that's probably what we'll move to eventually once we move off inject TCP. So that's probably a method to look into. Like demo time. This GIF is pretty apt because I was having some issues earlier actually. But let's hope that this actually works. If it doesn't work, I actually have a recording, so I've backed myself up. So let's go over here. What I'm going to do is I'm just going to watch these pop. So inside my cluster, and again, I'm using Docker for Mac Kubernetes. I have 2 different pods running here. I have QOTM, which is just a basic service that returns some sort of message, but you'll see why that's used quite a bit. And then I have my telepresence test deployment. I'm just going to show the service here. It's QOTM and it's running on port 5000. But if we just pay attention here, and I'm actually just going to show you what's in my telepresence deployment. So just open up this. There we go. Can you all see that? Even at that bit? Okay, cool. So if you've done anything with Kubernetes before, this will look pretty familiar to you, hopefully. It's a deployment. And what I'm doing here is I have an init container, but to show you the main container that runs in the pod here is just a busybox container. And what it's doing is it's taking this stuff data/random, which is what the init container is producing. So in this init container here, so an init container, if you haven't heard of it before, is a container that runs when your pod starts. So you can have a set of containers here that run in sequence when your pod is creating, and then after that is run, it'll actually run your main containers in your pods. So what I'm doing with my init containers, I'm just preparing my main container, and all I'm doing is echoing this this environment variable into this /data/random file. That environment variable, by the way, is being populated by this secret that I have here, and this random data key. And if I scroll down to the bottom here, this is the secret. It's basically just the string is basically just random data. It's base 64. And yeah, and the other thing is this is volume. So this is important because this volume basically gets shared between the init container and then the container that gets stuffed up in the pod. So that way, at /data, the stuff that gets populated in this volume here is then also going to exist at the same location in this container, and that's why I can tail it. So this is currently running here. And what I'm going to do is I need to live debug this service because there's an issue with it, so I'm going to run telepresence. And what I'm going to tell it to do is swap deployment. And we'll swap the deployment called telepresence test. And then if I want to here, I can also specify the method I want to use. By default, it uses the VPN method. I'm going to go ahead and use the default method. Because I haven't provided any other arms to it, it's going to go and just set up a shell for me inside this container. Sorry, not inside this container, inside my machine. So we can see we can really kind of password. So what it's doing here is it's telling me that it's starting up with the VPN method, and there's limitations to that. It's telling me that volumes are going to be routed at telepresence group. And I haven't specified any service to proxy to here, so this is just telling me that there's no traffic being forwarded from the remote deployment to my local machine, which is fine for this demo. And then it's just guessing the range of IPs for my cluster and setting up the VPN. And now it's dropped me into the bash shell. And if we have a look at I was watching the pods here, so if we have a look, what happened here is that it's actually kind of updated my deployment. So we see that the previous pod is terminating, but then we see this new pod come up, which is essentially what telepresence is doing to replace what was already running. And we'll notice that it goes through, so where it says init 01, this is basically saying that it's initializing, it's running that init container. So it's exactly the same stuff that I had in that deployment, except it's just swapping out the main container to a proxy to my local machine. So that way I get the same init container, I get the same setup, to fill that volume with that secret, and then it's going, that gets to running state, and then I lose the other pod. So inside here, if I just run ls, you may not have seen it before, but this is the same. It's the same. I'm in my local machine basically, in the same directory that I was before. I just happen to be in this special bash shell here. And what we also saw was that the volumes are routed at telepresence root. So if I go and see what's in here, we'll see that this looks like a root directory in a container. And if I go into that volume called data, I'll see that there's a file called random. If I cat random, we'll see it actually says random data. And we can have a look if I run a random view and grep for my environment variable. So we saw that this was the environment variable that was being populated from that Kubernetes secret, and it's got the value that we expect there. The other thing I can do is we saw that there was a service called QOTM, and it runs on port 5000, so we can actually curl this service from this container. Let's do that. And you can see it responds as we expect as well. We can see, that pod name here, host name matches the actual pod that's running in the cluster. So I think that's really interesting. What I've done here is essentially I've got this Kubernetes cluster, and it's running my local machine using Docker for Mac, but I could be running this in the cloud somewhere in GKE or AKS or whatever. And I'd have this environment on my local machine and be able to have all the service discovery and volumes and all that from that remote environment accessible from my local machine. I think that's pretty cool. So if I exit here, what happens, and we'll see this, we'll see what happens is telepresence will go and revert that deployment to what it was before, and I lose my connection with the basher. Let's see a more interesting example. So I'm going to actually show you what we're doing with kubeapps here. So let's see if I can make this bigger. So kubeapps, as I said, it's kind of a console for your Kubernetes cluster, and you can go there and you can create installations of Helm charts and manage them, as well as the service catalog and Kubernetes functions. You install it by you download the binary. You can get it from kubeapps.com or GitHub/kubeapps, github.com/kubeapps/kubeapps. And then what you want to do is, once you have a cluster that you've pointed to with kubectl, you can run kubeapps up. It will automatically find your Kubernetes configuration and then install all the components that kubeapps needs. I'm not going to actually demo that, but you can easily find it. And then you access the UI using this command, kubeapps dashboard, and what it does is basically creates a port forward from your local machine to our Nginx in the kubeapps environment in your cluster, and then opens that in your browser. So if I open this up here, I already have this environment running, refresh. So I installed a memcached chart. I can go into the chart and I can read. And if you've used Helm before, you'll notice this. This is the stuff that gets printed out after doing a Helm install. And you can kind of see all the different resources that are involved in that, involved in the deployment. You can delete it, you can upgrade it. If you go over here to charts, you'll see all the different charts. And it's just coming from the stable and incubator official Kubernetes repository. So you can just see the same charts that you see over there. And you can go to a particular chart and you can find out more about it. You can click deploy, you can pick a specific version and click deploy, set the values that you want and install it. We also have a tab here for Kubernetes functions, and then I'm also going to quickly show you service instance service catalog. So with the service catalog, I can go and I've connected this to the Azure Service Broker right now, but there are also service brokers from Google and AWS. But I can actually go and provision external services from Azure directly from this user interface, directly from my Kubernetes cluster. And then I could even connect that to a chart. If you have your own chart repositories, you can also add them in this configuration page at repositories. So you can just go the same kind of thing as the Helm repo add, and you can add the name, the URL. There's an authorization header option here as well. So if if your chart repository is backed by some sort of authentication, then you can add either basic or Bearer token here to make that work. All of this, by the way, is using the Kubernetes API. And just to demonstrate that, if I go back here, if I run kubectl get app repository apps, you can see I have incubator, stable, and service catalog with the same repos that I'm seeing here. So we make heavy use of custom resource definitions, for both the repositories, the functions, the applications that you launch. We read the config maps from Helm for the tiller state and process all of that to figure out what's happening here. The service catalog also makes heavy use of custom resource definitions as well. Actually, they have their own API server, in fact. So it's not actually custom resource definitions. It's actually their own API server, and they have their own APIs for that. And we just call out directly to the Kubernetes API to provision service instances. So as you can see, what we're developing here uses the Kubernetes API pretty heavily and integrates with it very directly. So it becomes very hard to develop in an environment like Docker Compose. We kind of need to mount our kubeconfig and have it then connect to the Kubernetes API in slightly different ways to how you do it in production. So this is where telepresence has been really useful for us, because we can essentially just start up a kubeapps environment inside an existing Kubernetes cluster, and then just use telepresence to swap out whatever service we want to work on, and just build out that service. So as an example, I'm gonna show you how we develop the the UI service. And if I run GTTL get pod session, keep apps here. How am I doing for time? I think I'm going a little bit over, I'm not sure. So this is the namespace. So you can see that there's this pod called kubeapps dashboard UI, and that's the deployment that essentially I'm going to swap out. So again, swap deployment. I have this written before. So I'm swapping the kubeapps dashboard UI deployment in the kubeapps namespace. I'm going to use the inject TCP method because that's going to work nicely for me. And then this is something I didn't do before. I'm exposing port 3000 to port 8080. So what this is going to do is it's going to proxy port 8080 from inside that deployment, inside that pod, to port 3000 on my local machine. So I'll run that. And we can see it says forwarding remote port 8080 to local port 3000. And then I'm going to run my development server, so I'm going to run yarn run start. That's going to start up. In the meantime, let's look at the page. It's Node.js, so of course it takes a little bit to compile. Okay, so now I have my local server running, and just refresh here. So I haven't changed that port forward. It's still port forwarding to. If I go with this connection is still open. This port forward to that pod, and I've just refreshed it here. But what I'm going to do now is make a change. So this is the source code. So the front end is a React app. And I'm just going to make a small HTML change here. Let's say hello. .con. And when I hit save, we'll just jump over to the terminal here, and you'll see that's going to compile. And once that's done, we'll just watch this. Automatically live reload. But again, everything else is talking to the Kubernetes API, and this was just as good as running before. And if I now go ahead and quit this, if we're quick enough, just watch the pods roll out here. So I'll wait for this one to be running. Now if I refresh, it goes back to applications. Yeah. So well, I know it worked. Great. Nothing went wrong. So I guess I'll close off with a little bit of a kind of marketing-y stuff. So Bitnami is hiring. Obviously, this is our office in San Francisco, but we have another office in Seville, Spain, which is also nice and sunny. But we also hire kind of wherever good people are. We're pretty remote at this point. So if you're interested in working on cool stuff like this, bitnami.com/careers.
So today I'd like to tell you a little bit about using GitOps in practice with a simple application, and I'll walk you through an example where I'll show how that actually is all set up with a CI system and a couple of tools that will probably come handy if you were to do the same thing. So, but to start off, I'd like to tell you a little bit about GitOps, what it is, so that we're all clear, we're all on the same page, and I'll then proceed to the example as I promised, and after that I'll tell you a little bit about some of the most recent things I've been doing. Yeah. So let's define GitOps. What is it? What's GitOps? Well,
an operation with a Git repository.
Yeah. Well, I think I have a very concise definition over here. It's really managing Kubernetes with everything in Git. And is it just configuration as code? Not exactly, right? It's not just configuration as code, because just configuration as code, the idea of configuration as code doesn't really imply how it's going to be applied to any given system. So with GitOps, we really have these three clear promises. First up, it's all declarative. Desired state and everything that expresses the desired state is stored in a Git repository and continuously reconciled by Kubernetes. This includes workloads, of course, but also potentially dashboards, alerts, and even any external resources, and potentially, cluster configuration as well. So there will be an operator in the cluster that looks at the desired state and the current state, computes some kind of diff, and figures out what needs to be. And that kind of diff can be always looked at and monitored in case there's something that is not as expected. So it's also fully deterministic, which is really thanks to Kubernetes, right? So as long as you express it correctly, Kubernetes will do the right thing. And first of all, obviously, Kubernetes relies on the immutable unit of deployment container, the Docker image, where if you put the right things in there, if you've done it in a good manner, you'll get it right. So that's obviously for some containers out there on the internet, maybe the quality varies, but you've got the right tools to your disposal to make it right. So secondly, Kubernetes has very well-defined APIs, which have really tight scope and well-known behavior, which is well documented that you can actually rely on. And thirdly, you can monitor every aspect of how things work in your GitOps setup. So you could use, for example, Prometheus to observe whether you've got all the pods running, whether all your pods are healthy, whether you've got the right number of deployments. And you can do these diffs on infrastructure as well, because it's all in Git. So that stuff's pretty cool, and it's a little bit, you get a little bit more insight, much more. That's a bit shy. You get much more insight than you would with the more traditional configuration management system, right? Something like Puppet could easily go wrong, and you would never find out what gone wrong all the way. And finally, the third and quite important piece is that Kubernetes APIs are all extendable. So you could actually, if you really wanted, you could make Kubernetes order pizzas once the team deployed the application, right? Given it's on a certain time of day when they're likely to be hungry. There are different ways you can extend Kubernetes APIs with custom resource definitions. And you could implement any kind of business logic, you can manage external systems, you can provision databases or anything like that. There are lots of different ways that we've been hearing about people use Kubernetes API extension points to manage just about anything. So you don't only store you don't only have to store the kind of the existing Kubernetes objects in your Git repository, but you can also store anything other than that you define through CRDs. And unlike certain other systems, such as, for example, Terraform, right? It relies on external state and it doesn't do reconciliation for you. So the important part here is that actually with Kubernetes, you have this constant reconciliation loops going on. And you don't have to rely on the external system to give you the correct state. You can just enforce the state that you need. So if that's not enough for some of you, I think that there's this very different way of explaining why do we really care about GitOps, and it would be by comparison. By comparison to something what I call CIOps. So CIOps is this really naive, simple way to deploy apps to Kubernetes, right? You write a shell script or makefile that runs Docker build, runs Docker push, great, and then it runs kubectl set image straight from the CI job. And I've done it myself a number of times. I kind of work for simple apps. One cluster, a couple of simple apps. That kind of works, right? But there are a few concerns that I have with it once it goes beyond that simple use case. First of all, like, are your CI jobs interlocked? Is your colleague's CI job gonna jump ahead of yours or not? How do you tell? That's, there's probably a way to do that in certain CI systems, but it would be implementation dependent. And what if your colleague decides to try another CI system? How are you going to ensure that you're all doing the right thing? And what if they make a mistake and they're intending to update their job, but by mistake they're trying to update your deployment, right? They're intending to update their thing, but accidentally they override yours, or any other configuration changes. And what do you do about multiple clusters, right? Are you going to have like a separate definition of a CI job per cluster, or how are you going to go about this if you were to drive your clusters this way? So that's one other big question. And what happens if you had to rebuild a new cluster? And now what do? You get to rebuild all of your containers and do all of that? And how long that's going to take if you have dozens of microservices? Right? Well, perhaps you can optimize that part, but do you really want to be in that place where you're worried about how long it takes to rebuild all of your containers? You shouldn't have to rebuild all of your containers or manually rerun any CI jobs. Of course, you could automate that, but that sounds like a lot of work to me. And some people suggest that running CI inside a cluster is a thing. It is a thing, but it doesn't answer many of those questions. It sort of helps you with the configuration, the multi-cluster part, but now you end up with like different images actually, because you have to run separate registries for separate clusters. So that stuff gets a bit out of hand, because you would have this sort of minor image drifts, and I think that's one really bad problem that you can end up with when you have this slightest doubt about the system, right? Whether you're not entirely sure whether this image here and this other image here are exactly identical or not quite. And you'll need to have tools to match those up, and why should you worry about all that stuff as well? And why should you run CI jobs in your production clusters as well? I mean, they could easily be pretty resource hungry. Unless you want to get into the business of separating out like node pools or anything like that, and making sure that the CI jobs run on certain machines and everything else runs on different machines, maybe that's the thing. But why should you worry about that kind of minor detail, just in order to get things deployed? And actually, this is probably the biggest one. How do you actually roll back if you do this kind of thing? You probably have to make a manual change inside the cluster, right? So, and there's this final one where actually we can take a look at what everything that goes on here. That, like the developer pushes code to op repo, there's a CI job being triggered from there, and there's a container registry, right? And most of these things have a read-write access to at least one or two other things. So it's kind of messy, I'd say. And how do you know what is the source of truth here? With GitOps, the source of truth is here in the configuration repository. There is an operator that applies what's in the configuration repository to the cluster. All CI has to care about is build and push images to a registry, and developers doing what they're doing, right? And whenever they want to make a change to the cluster, they'll make a pull request to configuration repo and propose a change. So this is sort of the GitOps model at a glance. At Weaveworks, we have additional control loops in here to help you with deploying the latest images and such. We'll look at that a bit more closely in the second part of this talk. Any questions so far before we get to the example? Okay, good.
CIOps, you said there is no source of truth because there is only one repo that is the app, right? That's the source of truth, right?
Well, there will be multiple app repos, right? There will be like multiple microservices. Mm. And how do you know which one is going to the right cluster and where are they?
It's like a meta repository that you need for.
Right. So with the config repo, there's a meta repository where all the YAML files and anything else you need to have to go along with that, documentation perhaps. So in some cases, the configuration repository can be the same as the app repository if you like monorepos, but you'll have to take care of certain things not to happen. So whenever there are changes to the config, you don't want to rebuild the images because you could get a loop. So you want to avoid that, but that's totally doable to avoid. So in this example today, I'll show you a simple app which would be hooked up to Circle CI. You could use any CI instead. It will push to Docker Hub, and we'll be using Scaffold to run the builds and push them. Scaffold gives you a benefit of like switching between different modes of development. I'll show you a little bit of that as well before we get to it. And we'll use vCloud, GitOps operator. I'll show you the commercial version of vCloud and the open source version as well. So a little bit about Scaffold. How you'd use Scaffold is this. So as a developer, you can use Scaffold to build images, tag them, push them to a registry if needed, if you're using a remote cluster. If you're using local clusters, Scaffold won't bother pushing images. It has the ability to detect that. You don't have to write a makefile to do that. And you can also watch for local changes. As you make changes to code, it will keep updating the running deployment. Or replica set if you like, or anything like that. So any Kubernetes workload really. And then when you push changes to the Git repository, we haven't tested them locally, you push them to the Git repository, there's a CI job that triggers, which can also run Scaffold. That's what we're going to show. It will run Scaffold to tag the image and push it to the registry. And you can also touch the Kubernetes cluster for you as well, but that's CI ops, we're not showing that. We disable that functionality, and Scaffold is pretty good at allowing you to only use certain parts of functionality, and we will use the GitOps operator there. So for the local development, this is the kind of config file you'd want to write. You pointed at a Docker file for the build, and for deploy, you pointed at manifests. And those could be deployments or replica sets or daemon sets or anything like that. You can actually support multiple workloads as well. So once you've written this kind of file, you could use it the way I do or somehow else, where I have some code here that I'm working on, and here's Scaffold running constantly. And there's another terminal that I'm using for all the different things that I do. And whenever I make changes, it builds them, deploys them to my Docker for Mac. It could be GKE too. It's entirely transparent. So, and what I don't have to do is maintain this little make file that I wrote one day, which did some interesting things, but I don't even want to talk about it. So here's the kind of GitOps setup. So we're still doing that local development, as I said, pushing to the code repo. CI jobs run, push to the registry, Scaffold runs there. Scaffold runs in the local development, of course, as well. And then we have vCloud operator here. We have the, as I said, there are a couple of extra control loops. There's the image sync control loop. We look at the registry for latest image tags, and based on policy, we were able to update those. So you can differentiate the different tag prefixes and such things. And there was the config sync loop that synchronizes it with the cluster. It's pretty simple, really. And there's a UI as well, of course. So we need to extend this Scaffold YAML to run it in CI. We keep the build and deploy steps as they are. That works well for Scaffold Dev. For Scaffold build, we want to define profiles. We define a test profile and production profile. And here's the test profile. It's actually pretty simple. It just runs Docker build. But it doesn't push anywhere. So we can have a clean build. And if that exits successfully, we proceed to the production profile, which does the same thing but relies on cache and pushes. So skip push is false. Should we really take that line out? Because that's the default. So, and the deploy step is not there at all because we're going to be using the Weaveworks GitOps operator. And here's the circle config. We have two jobs, test and deploy. We'll define those momentarily, and there are the workflows here to do with those jobs. The test job runs first, deploy depends on that, and deploy only runs in master branch. So the test job uses the Docker image that includes scaffold. There isn't an official image for scaffold yet. I had to build one. I'm contributing the Docker file to the repository and the process of that. And it checks out the code, the stuff they do with Circle. This is a typical Circle stuff. And then runs the command scaffold build profile test. So they'll just run unit test and build the image. And the next step, we'll do Docker logging and rerun Docker build and production profile in action push. It's really quite simple. So how do we set up the GitOps operator? As we saw earlier in this repository, we have deploy scaffold directory, and there's a dev directory that we saw earlier. Maybe I forgot to highlight that, but it was there earlier. And we have the production directory in there as well. I can show you the layout, but it's really pretty simple. There are just some YAML files in there. And we point at the master branch, right? So we would go to the Cloud UI and configure deploy functionality here. We have the Git URL, path, deploy scaffold production, and branch master. So we've done that. We apply a change to the cluster. After that, we shouldn't have to worry about kubectl anymore. We just put everything through the repository. As I said, there is the open source implementation of the operator that runs under the hood. To configure that, this is essentially what you need to do. There is a bit more to go with that, but essentially you put the same information as arguments to this Flux pod. And once the circle runs and pushes the image, we'll see that image appear in the list of tags here in the Cloud UI and be able to release that. And yeah, should be that already. So once again, it's declarative, deterministic, and extendable. You can extend APIs whichever way you like. Obviously, making a pizza may be a bit of a hypothetical example, but it's more than configuration as code because you have these three promises, and you can obviously extend. It's not just some config files that you copy into Etsy posts or some Docker files or anything like that. It's a little bit more than that, and there are some clear promises to go with. So in the last bit, I wanted to mention the Dev Toolkit. As we heard today, there are interesting tools like telepresence and the scaffold, and there are a few other things. Michael Hasselblatt of Red Hat and myself wrote this blog post earlier on Kubernetes blog. We've been talking about some of these topics in the office hours, so please join our office hours. Perhaps next Thursday, perhaps the Thursday after, we'll be doing it every week, every Thursday. And we've covered some of these tools. We covered telepresence, we spoke earlier today, and scaffold, also draft, ksync, and squash are covered in this blog post. We're hoping to write a follow-up with some of the things that came out more recently. There's been a lot of stuff going on. And one of the things that I've been involved with is the EKS crawl. It's got a cute logo. And it gets you set up with Amazon EKS pretty quickly. It's just a single command. I'll be talking about it tomorrow at CloudCamp. And check it out on ekskadol.io. So as promised, the office hours link is here. That's bit.ly VUG, Viv user group, and it's every Thursday. Come and talk about these things. It's supposed to be interactive. So please join and tell us what you think about all these different topics. And thanks.
What time is that?